Hi, welcome to the tutorial on the pandas.groupby function. By the end of this tutorial, you will be able to explain the use of pandas.groupby function and implement it. In the previous tutorial, we have already seen that we can easily calculate the mean, median, and mode of the different columns of any data frame by using a simple pandas or numpy function, such as dataframe.mean function or np.mean function, dataframe.median function or np.median function, or dataframe.mode function, etc. So far, we have seen the basic functions in pandas and numpy and matplotlib, and we use them to carry out basic operations such as importing the data, exploring the data, calculating descriptive statistics of the data, and visualizing the data. Now let's consider a scenario where we want to calculate the mean of a column with respect to another column. Confusing, right? Let's have a look at the columns of the dataset again. Note that we are importing raw_housing_prices.csv as data for the sake of simplicity. Now we have already seen that we can calculate the mean of sale price of the houses by simply calling the mean function. Now consider that you are trying to find a relation between the condition of the house and the sale price. A question might come up in your mind. How does the condition of the house affect the sale price? Unfortunately, we cannot calculate the correlation between the categorical and the continuous variables. So, what do you think we should do? A good way is to calculate the mean of the sale price with respect to the condition of the house. So, let's try to do that. We start by declaring a new column in the data as condition_sale and initialize it to 0, which means all the values in this column are 0 to begin with. Then we run a loop for every unique value in condition of the house, which means that variable I will take the unique values in the column condition of the house, which are fair, excellent, good, bad, and okay. Now let's break down this complex statement which we have written here. On the left hand side, the expression follows the syntax data column name condition. We are already familiar with data column name, but the next part is something we are looking at for the first time. Let's understand it in plain English. Consider that variable I takes a value good from the condition of the house. Please note here that variable I would already be string data type. But just for precaution, we have used the str function converts the value of I to a string data type explicitly. So going back to our statement, it says in the column data condition sale, select all the rows where the condition of the house is good. Similarly, let's look at the right hand side of the expression. This statement in plain English would mean select all rows in data sale price where condition of the house is good. And the mean function calculates the mean of all the rows that satisfy the condition. In essence, you calculate the mean of the sale price corresponding to every unique value in the condition of the house and store it in the new column that you created. Once the process is done, we simply visualize the mean of sale price with respect to the condition of the house. And we can clearly say that the houses in excellent condition have the highest mean sale price and vice versa. Now let's consider that I want to dive deeper and want to find out the mean sale price with respect to both condition of the house and zip code. That would give me much more detailed results. So let's try to do that. Here we are saying the exact same thing what we did the last time, except we are using two conditions to calculate the mean, which are condition of the house and the zip code. The syntax we followed is data column name condition 1 and condition 2. And at last we check the number of different values we have obtained for the zip underscore condition underscore sale as a result of combining two conditions, zip code and condition of the house. Here the data zip underscore condition underscore sale dot unique returns the unique values in the column. And the len function counts the number of elements or the number of unique values in this case. As a result, we have obtained 281 different values of mean corresponding to the unique combination of the categories, condition of the house and zip code. But there is a problem. The code we just wrote is complex and not comprehensible. Also, if you might have noticed, the code took a while to run. So we can say that the code we wrote was inefficient. Is there any solution? Luckily, the pandas library has advanced functions which reduce this operation to a child's play. These are pandas.groupBy function and the pandas.pivot underscore table function. Look at them one by performing the same operation of finding the mean of the sale price with respect to the condition of the house and zip code. We will start by pandas.groupBy. For this, we will simply create a variable by the name of zip underscore condition underscore sale. Then we call the function groupBy. Note that syntax of groupBy is data frame dot group by list of columns to group by column to be grouped dot how underscore to underscore group function. As we need to calculate the mean sale price with respect to condition of the house and the zip code, we pass these as the list of columns to group by. We are grouping sale price, therefore we specify sale price as the column to be grouped. At last, we simply call a function how we want to group the data, which we are doing by using mean. On running this cell, we get an organized output, where the first column represents the condition of the house and the second column contains unique zip codes for given condition of the house. The third column is of our interest. It contains the means of sale price with respect to the condition of the house and zip code. And we can clearly see that the code is clean, short and comprehensible. Also, the output is formatted better in this case. But pandas.groupBy function has certain limitations. It cannot perform very complex aggregations and the formatting of the output cannot be changed to suit our needs. To counter this shortcoming, we have another function from pandas which works very similar to pandas.groupBy function. It is called pandas.pivot underscore table. It essentially does the same thing that we have already done twice before, but it can easily handle more complex operations and provides better representation. In our next tutorial, we will discuss more about panda pivot table function. See you then.